7.2 Scale diagrams and reductions. Here's a map of Victoria Island from the internet. What is the scale on the map? How is the scale used? If you look at the map carefully, at the bottom, in most cases you will see such a kind of line segment. So from 0 to 100, this unit is 100 kilometers. If you use a ruler to measure this part, it's about 1 centimeter long. So they use such a kind of 4 centimeters line segment to represent 400 kilometers. One portion, which is 1 centimeter long, represents 100 kilometers in the real life. So on the scale length, 1 unit length represents 100 kilometers. How can we use the scale to find the real distance between two locations? For example, from Cambridge Bay to Holmen, I can use a ruler to measure the distance between these two locations on the map. Then I use the scale factor and the distance, or we can see the length on a scale diagram to find the length on the original diagram. Let's review a scale diagram. A scale diagram can be smaller, this is a reduction case, or larger, enlargement case, than the original diagram. To calculate the scale factor is the ratio of length on scale diagram to the length on original diagram. If we look at the original diagram here, its scale diagram is the large one. So we will see this one is an enlargement of the original diagram. Therefore, the length on the scale diagram should be larger than the length on original diagram. So if we use these two numbers to form a ratio, this ratio, which is the scale factor, should be greater than 1. So later on, we also can know if the scale factor is greater than 1, we will know the scale diagram is an enlargement of the original diagram. Reversely, if we have a big original diagram and a smaller scale diagram, so this scale diagram is a reduction of the original diagram, then the length on the scale diagram is shorter than the length on original diagram. Therefore, the scale factor value is less than 1. Example 1. Here is I love math button and its reduction. Determine the scale factor. So let's find the scale factor by looking for the diameter on scale diagram and the diameter on original diagram. Since these two diameters are not given in the question, so I will use a ruler to measure how long the diameter is in both of these two diagrams myself. So if I use a ruler, I will see the diameter of scale diagram is around 1.7 centimeters. So let's measure how long the diameter is in the larger diagram. You can see 2.55 or 2.6. So let's just say it's 2.55. This is the diameter of original diagram. So the ratio, which is the scale factor, is 1.7 over 2.55. If I use the calculator to help me find this value, it's around 0.666. It's a repeating decimal with 6. So if I wanted the exact value, I would write down 0.6 repeating bar. So right now, let's find the height of heart on scale diagram and the height of heart on original diagram by using the ruler. If I use this ruler, I will get to the height of heart on scale diagram is around 0.35 centimeter. If I use the ruler to measure the height of heart on original diagram, this height is around 0.525. It's just around there. And 0.35 over 0.525 is around 0.666 again. If I want to get the exact value, this one is 0.6 repeating bar. So pairs of corresponding lengths are proportional because these two ratios are equal. And the scale factor is 0.6 repeating bar. Example 2. Drawing a scale diagram that is a reduction. Draw a scale diagram of this octagon. Use a scale factor of 1/2. Or 0.5. We all know that a scale factor can be expressed by a fraction or a decimal. So here we have all the dimensions of the original diagram. We need to determine the length of each line segment in the scale diagram by multiplying each length on the octagon by 0.5. The new lengths will be 0.5 times 2. So this one, if I shrink this one by a scale factor 1/2. This one will become 1 centimeter. 0.4 times 4. Here is 4 centimeters long in the original octagon. If I reduce this one by 1/2, so 4 centimeters will become 2 centimeters. So this one is also 2 centimeters. This one in the original diagram is 6 centimeters long. And this one is also 6 centimeters long. This one is also 6 centimeters long. If I reduce those 3 red lines by 1/2, I will get 0.5 times 6 centimeters. It's 3 centimeters long. So the green line segments will become 1 centimeter in the scale diagram. The blue lines will become 2 centimeters, and the 3 red line segments will become 3 centimeters each. So right now, let's graph this octagon in the 1 centimeter grid. I will start from this point. 6 centimeters become 3 centimeters. This 6 also become 3 centimeters. This also become 3 centimeters. This 2 centimeters right now is 1 centimeter long. 4 centimeters right now is 2 centimeters long. 2 become 1 again. 4 becomes 2. And this one, which is 1, for this 1/2. So this is the scale diagram of the original octagon. And you will see this one is a reduction of the original octagon. And the scale factor is 1/2 or 0.5. So right now, let's apply the scale diagram to determine length in the real-life problem. Here is a scale diagram of the top view of a truck. The actual truck length is 3.25 meters. The scale is 1:50. This means that 1 centimeter on the diagram represents 50 centimeters on the truck. So the scale factor is 1/50. Let's solve the following. On the actual truck, the front and the back wheels of the truck are 2.7 meters apart. How far apart should the wheels be on the scale diagram? So this one is the length in original diagram. If I want to find the length on the scale diagram, I will use the original diagram times the scale factor. But before I multiply the scale factor by the length on original diagram, make sure that units of length must be the same. Therefore, I will convert 2.7 meters to centimeters. 2.7 meters to centimeters, I need to multiply by 100. So it's 270 centimeters. Each distance on the scale diagram is 1/50 of its distance on the actual truck. So the scale factor times the length on original diagram, which is 270 centimeters. So this one is 1/50 times 270 centimeters. This one is 5.4 centimeters. So that means on the scale diagram, the wheels are 5.4 centimeters apart. So this is the drawing length between the front and the back wheels. What is the width of the actual truck? So if I want to find the actual width of the truck, I need to measure this drawing length, which is the length on scale diagram, by a ruler. So from this side to that side, it's around 2.7 centimeters. So I will take the width is around 2.7 centimeters in the scale diagram. Each actual measure is 50 times as greater as the measure on the scale diagram. So when I have the length on the scale diagram and I want to find the length on original diagram, I will use this length on the scale diagram divided by the scale factor. This division will give me the length on the original diagram. So my scale diagram is 2.7 centimeters, and my scale factor is 1/50. So if I use 2.7 centimeters divided by over 50, I can get to the original, the length on the original diagram. 2.7 centimeters divided by 1 over 50 will be the same as 50 times 2.7 centimeters. So this is the reason why we say each actual measure is 50 times as great as the measure on the scale diagram. This 50 is the reciprocal of the scale factor. So the actual width of the truck is 50 times 2.7 centimeters. This result is 135 centimeters. Therefore, the truck is 135 centimeters wide, or I can convert the centimeters to meters, which is 1.35 meters wide. Example 4. Let's complete the table based on different given conditions. The first one is we know length of original, length of scale diagram. We want to find the scale factor. If we want to find the scale factor, we use the length of scale diagram divided by length of original. So it will be 24 centimeters over 12 centimeters. Cancel the units, centimeters. We will get the scale factor 2. If I know the scale factor 4 and the length of original is 9 centimeters, if I want to find the length of scale diagram, I will use this scale factor times length of original one. Then I will get 36 centimeters. And you also can decide whether this length of scale diagram should be longer than the length of original or shorter than the original one, based on this scale factor. Because this scale factor is 4, which is larger than 1. So the scale diagram should be an enlargement of the original diagram. If this one is an enlargement, so the length of the scale diagram should be longer than the length of original. So this is the reason why I can understand that I need to use the multiplication to find the length of scale diagram. So the next one is I know the length of scale diagram and the scale factor 1.5. And the scale factor is 1.5, which is greater than 1. So from this one, I can know the scale diagram should be an enlargement of the original diagram. So the length of scale diagram should be longer than the length of original one. So I will use 48 centimeters, which is the length of scale, divided by the scale factor. So 48 divided by 1.5 is 32 centimeters. And the 32 centimeters is really shorter than 48 centimeters. The length of original one is 25 centimeters. The length of the scale diagram is 5 centimeters. If I want to find the scale factor, this one is very easy. I use 5 divided by 25 centimeters. Reduce the units. This fraction can be reduced to 1/5. You also can change 1/5 to a decimal, which is 0.2. So the scale factor is 0.2. And from this scale factor, we can see the scale diagram is a reduction of the original diagram. So this is the reason why this one, the length of the scale diagram is shorter than the length of the original one. So right now I have the length of scale diagram, which is 10 centimeters, and the scale factor is 0.1. So 0.1 suggests that the scale diagram is a reduction of the original diagram. So if I want to find the length of original one, I use the scale diagram divided by the scale factor. So 10 centimeters divided by 0.1, which is 100 centimeters. You also can use 10 centimeters times the reciprocal of the scale factor. So the reciprocal of 0.1 is 10. So 10 centimeters times 10 is 100 centimeters. The last one is the length of original one is 14.7 centimeters. I need to look for the length of scale diagram. And I also know the scale factor 0.6. So if I want to find the scale factor, the length of scale diagram, I will use the scale factor times the length of original diagram. 0.6 times 14.7 centimeters equals 8.82 centimeters. Since the scale factor is less than 1, I will know the scale diagram is a reduction of the original diagram. And right now, the length I found in the scale diagram is really shorter than the length of original one.